Okay, hey discrete math students, how are you? This is the video that I promised. Let's go over those 5 problems that I assigned for your project. You're supposed to pick only one of them, not all 5. You pick one of them and then you code it up using either Mathematica or Python or Racket. Okay, so I think most of you are really into Python. That's okay. Python is a very good programming language. It's a very popular programming language, and it's probably a little easier to learn than, a language like C or C++ or Java or C Sharp. Those are pretty complex languages. Python is a little easier than those languages. Um, Bear in mind that, Python, for what we're doing in this class, Python is fantastic. Mathematica is fantastic. And by the way, Racket is pretty fantastic too, although it has a syntax that some of you might be uncomfortable with. But bear in mind that if, many of you are going to get a degree in information technology or computer science or something like that, machine learning or, cybersecurity or, some field related to computers. And I hope you have to understand that for some things, Python is just not going to be enough. For some things, you got to use a language like C or Objective C or C Sharp or C++ or Java. A good example would be operating systems. Okay, if you're building an operating system or if you're modifying an existing operating system, I don't think you can use Python for that. For that something like that, you need a language like C or C++ or Java or something like that. So, I hope you guys. Python is a great language, but depending on what you're into and what you're interested in, you may have to explore other programming languages as well, not just Python, okay? So, that's something you need to kind of, keep in mind. Okay, so let's go over these problems. So let's see, we have 1, 2, 3, 4, 5. Okay, let's take a look at the first one. Given 2 strings of characters, use the naive string matching algorithm. Excuse me. Use the naive string matching algorithm to determine whether the shorter string occurs in the longer string. Let's see, the cashier's algorithm. Okay, let's see here. Okay, so let's give this a whirl. What should I use? Should I use Mathematica or should I use Python for this one? I'm going to use Python. I'll use Python for number 7. I could use Mathematica. I could even use Racket. I'm going to use Python. So, given 2 strings of characters, use the naive string matching algorithm to determine whether the shorter string occurs in the longer string. Okay, so let's go ahead. Oh, I have to do a system preference update. Okay. Um, let's go ahead and do this in Python. Let's see, how do I want to do this? Okay, let's do it like this first. Okay. Okay, so I'm using IPython, which is part of the Anaconda Python installation. Anaconda is really good. You don't have to use it, but I recommend it because not only do you get the Python programming language, but you get dozens of third-party libraries that greatly extend the functionality of Python. So I really recommend it. So for this problem, I think I'm going to use a list comprehension. I love list comprehensions, and you will find them in Mathematica and in Python and also in Racket. So let's say I have a message or a sentence. I really dig the Python programming language. And let's say that I want to break this up into words of length 3. Words of length 3. How would I do that? Let's see. Sentence. So we have x plus 1, x plus 2. Okay. For x in range, well, we're going to start with 0. Okay. Strings, in Mathematica, it's different. Mathematica, in Mathematica, the first index is always 1. In Python and also in Racket, the first index is always going to be 0. All right. So by default, we start with 0 anyway, so I don't have to put 0 there. This would be, I believe, length. Now remember, in Python and also in Rackets, this value, you don't actually go up to the final number of the range. You go up to the number just below. All right, which gets a little confusing sometimes. So the length of sentence, I think we would do -3 or -2. Let's check. Oh, that's not, hold on. Let me turn pretty printing off, because otherwise it's really annoying. It can be annoying sometimes. My sentence, okay, I don't think I went far enough. Oh, and you know what else? Because, okay, the range, so there's a range problem happening here too. So, yeah, I have to go, this should really be x plus 3, because when I do the slice, I'm not going to get the third, if I have x plus 2, I'm not going to get the third letter, so that would be bad. So okay, my picture here is getting in the way a little bit, but I guess that'll be okay. Let's try this again. We're going to try this with x plus 3. Let's see if I have the effect that I want. Okay, so this is almost what I want, but not exactly. So I have, remember, spaces are characters too. I space R and space RE and then REA and EAL and etc. etc. Okay, so this works. There we go. This works, but there's one little problem. Can you guys see what it is? What am I missing at the very end? At the very end, I am missing my exclamation mark. Okay, so we can fix that like that. And now I have my exclamation mark. So I was able to break up my sentence into blocks of 3 characters each. All right, I was able to break up my sentence into characters of 3 characters each. I was able to break up my sentence into blocks of characters where each block contains 3 characters, okay? All right, so how can we turn this into a function? Well, I think I'm going to open up, let's see, Homebrew, okay. Let's go over to Python, my Python directory. Okay, and let's say, I'm going to have to turn, you know what, I have to turn this off because otherwise this is not going to work. Quit. Okay, so let's say, I like the Emacs text editor. Everyone, use whatever text editor you want to use. Some people use PyCharm. Some people use Sublime, some people use Eclipse, some people use Vim. Everyone has his or her favorite text editor. I happen to like Emacs. I've been using Emacs a long time. I used it when I was doing Java programming. I've used it for Python programming, for Haskell programming. I happen to really like Emacs, okay? But everyone's going to use a different text editor, right? So what should I call this? How about word in sentence.py? Okay, and we're gonna start with, I'm gonna change my colors. How about Molokai? There we go. Douglas E. Lewitt in Math 144, Section 0, Section 0C1. Writing a function, writing a function that determines whether a word is contained, or whether a, I should say, whether a substring, whether a substring is contained in a larger string. Okay, and this is the kind of thing that I would expect, guys. I really want you to put your name at the top of your work and identify which problem you're doing. Okay, you could just give me a bunch of code, but then I'm like, wait a minute, you know, where's the name? Where's the course number? Where's the section number? Why didn't the student identify the problem that's being worked on? You know, that's kind of important stuff, right? It's important in any class that you take, all right? So then I could look over here and I could say, let's see what I did here. Okay, so I'm going to have a function. We use the def keyword to define the function, okay? Word in, well, actually, no. You can't use the minus sign. You can do that in Racket. You can't use the minus sign to, when you're identifying the name, when you're creating the name of a function, guys, you cannot use the minus sign. You can in Racket, but not in Python. So word in string, and we're going to have, let's say, sentence or message. I could call it message, whatever you want to call it, message word. Okay, and this function, word in string, this is called my doc string. And you could use single quotes. I mean, it's kind of up to you. I like double quotes. Most Python programmers use single quotes, but it really doesn't make a difference. Word in string returns a Boolean value. Okay. If word is part of message, the function returns true. Otherwise, the function returns false. Okay. Now, do you really need a doc string? That's called a doc string, by the way. Okay. Technically, you don't need it. A lot of Python programmers will include a doc string at the very beginning of every function that they write. And the reason is because it sort of tells you, like, okay, what is this function supposed to do? Do you really need it? It's not technically necessary, but it is considered good, good programming style if you include a doc string in your Python functions, okay? Okay, so what are we gonna do here? So let's do something like this. Word length is equal to the length of word. Okay, how long is my word? And then we're going to do, let's see, -2. Okay, I'm going to follow my example. So message x plus word length for x, and you don't have to call it x, guys. I don't care. Give the variable whatever name you want to call it. C, you could call it C for character. That's fine. I like X because I'm a math teacher, but you could call it C. Call it whatever you want to call it. All right. For C, you could call it a car. For character, whatever you want to call it, as long as it's meaningful to you. For car in range, this is going to get a little, this part's tricky. So what did I do over here? The length of the sentence -2, length of the message minus, that's going to be the word length plus 1. Let's see. We have to use the return keyword in Python. Return word in. Is the word in that list? Is the word actually in that list? I believe this should work. I mean, there might be an issue if the word is longer than the message, but I don't think so. Let's try it. We're going to give this a shot, okay? So we're going to save that. Okay. And so let's say I'm doing this. I space, well, let's do this. Let's bring that back. Look at the first, well, it's, I guess you could call it a word. I space R. I space R, is it in that list? And it's true, okay? We can see it right over here, right? We can see it's the first block of characters. If you want to call it a word, you can call it a word. So let me see. Is that going to work? So IPython, okay. And then from, oh, let me see. I called it word in, oh, I'm going to have to change. Wait a minute. I just see what wait. Let me, hold on one second. That's a little better. Sorry about that. I hope the volume's okay. Let me, you know what? This is going to be a problem when I do my import. So what did I call it? Word in sentence. Let's change that. Word in sentence. We're going to rename it. Word in sentence.py. What if my module name and function name are the same? Is that going to be a problem in Python? I don't know. Let's see. Word in, I don't think so. Oh, I called it word in string. I called it word in string. Actually, I could probably call it word in sentence. Let me change that. Word in sentence.py. Okay, I'm going to call it, let me change those colors. Molokai. There we go. I'm going to call it word in sentence. It's a little weird, so the function name is the same as the module name, but I think that's okay. Word in sentence. Okay. Okay. So now I really should get rid of that copy. Let's see. Oh, what the hell did I just do? No. Okay, that is not, sorry about that. Let's try that again. Oh, I see what I did. I did. There we go. Yeah, I see what I did. Okay. There we go. Okay. Ignore that. Ignore that. There we go. Let's clear this. Sorry. Okay, so let me see what I'm doing here. So IPython. Okay, from word in sentence, import everything. Oh, let's. Pretty printing is off. And my function is right over here. Now let's give this a shot. Word in sentence. Well, it's Halloween, right? Well, almost Halloween. Tomorrow is Halloween. So Halloween, and then ween, true. Word in sentence. Halloween is fun. No, let's just do Halloween. Now, what happens if the word is too big? It should be false. Halloween is great fun. There we go. It works because we're going to end up with an empty list. We're going to end up with an empty list. So if you have like Halloween in the empty list, of course, the answer is just going to be false. So word in sentence, ghost, and host. It's true. Word in sentence, ghost, and ghost. Word in sentence. And we could do, let's see, witchcraft, witch. This should be true. Now this is going to be false because Python is case sensitive. Lowercase w is not the same as uppercase w. That's going to be false. So if you're doing an assignment like this for me, okay, so this time with the first project, I'm going to be, very lenient and kind of, grade pretty easily. But with the next two projects, guys, I am going to be stricter. I'm going to be much stricter. So what I would expect you to do is something like this. Word in sentence.py. What I would like to see, let's change. I'll use Manage Dark this time. Okay. What I would like to see is something like this. I want to see test cases. So for example, sentence 1 could be equal to, or let's be consistent with the names of my variables. Message 1 is equal to, let me see, Halloween. Word 1 is equal to hello. Message 2 is equal to, are you afraid of ghosts? Word 2 is equal to ghost or ghosts. Okay. Message 3, let's see. How about witchcraft? Word 3 could be craft. So I would expect these first 3 test cases to return true. They should return true. Okay, they should return true. And then let's write a test case that's going to return false. Message 4 will be pumpkins. Word for will be let's see. Do you like to carve pumpkins? Okay, this will return, actually, let me put a question mark there. This will return true. No, actually, this is going to return false. This is going to return false, okay? And the reason that's going to return false is because the word is much bigger. It's bigger than the message. This is going to return false. And then if we reverse it, it's going to return true. So this is going to return, this will return false because the word is bigger than the message. The word is not contained in the message. The message is it's too small, right? But if we reverse it, it'll return true. So my expectation is print, well, let me see here. My expectation is this. Let's test it. Word in sentence, message 1, word 1 should be equal to true. And we're going to, sorry about that. We're going to print that out. Let's print it out. Okay. And then print word in sentence, message 2, word 2. Actually, you know what? I'm going to put, just to make sure I'm getting that last character, let me put a question mark there. And that should be equal to true. Let's print it out. Okay. And let's see, sentence, message 3, word 3 should be equal to true. Okay. Print word in sentence, message 4, no, this should be word 3, message 4, word 4, that should be equal to false. But if I switch them around, word 4, word in sentence, sorry about that. But if I switch them around, I should have true. Okay, so let's see what we have over here. And let's do some spaces here. Print. And we could do another print. There we go. Okay. Python 3, word in sentence.py. Yeah, it's all true. It's all true. Okay, and that's what I would expect. That's what I would expect. So my test cases confirm that, you know, my function should work. Another thing you can do in Python, I don't do this. I haven't done this in a while. I believe you can use an assertion. I believe you can use an assertion. Google. Assert in Python. I haven't done this in a little while. Let me see here. Yeah, so you could do something like this. Well, I haven't done this in a little while, so you could do sentence.py, and I believe, hold on one second, what is the correct syntax? Okay, shouldn't you use parentheses? Interesting. Okay, so you could do, let me see here. Assert, I think the way I learned it, you're supposed to use parentheses. Assert, let me see, word in sentence. Here, let me change my colors a little bit. Deeper blue. Word in sentence, hello world. World, oops. World, and that should be true. Assert word in sentence, hello world. World, so this will be false. I believe you could do that too, but I don't know if we have, do we have to print that out? I'm not sure if we have to print that out or not. Let's see. Okay, let's save it. Let's save our changes. Okay. And 3, word in sentence dot py. Oh, we should actually, we have to print that out. We would have to, hold on one second. Do we have to print that out? If condition returns false, assertion, oh, so we didn't raise an assertion error. Okay, if condition returns false, assertion error is raised. So I'm curious, okay, okay, I'm relearning something here too. Sentence.py. What happens if, okay, let's see. Let's switch these around. We'll make this false, and we'll make this true. Okay, that's my phone, just ignore it. Okay. Let's see, Python 3. Yeah, so we have an assertion error. So if my assertions are incorrect, I'm going to, raise I'm going to raise an assertion error. So yeah, that works. Okay, so let's so I really should switch those around. So this would be true and this would be false. So we could actually maybe just, okay, if, and then print true, else print false. Okay. And this would be, okay, one second. If, just ignore the phone, guys. Print true, else print false. Okay, I believe that should work. Let's see. Okay, it sounds like someone left a message for me. I may have to check that. Okay, so let's see what we have over here. Oh, syntax error, invalid syntax. Why is that a problem? Um, so I can't use that as a conditional. That's interesting. I can't. Okay, so let me change that. Well, we know it's true. We know the assertions are true because if they're not true, then we're going to we would raise an exception. So that's interesting. So, um, yeah. I mean, actually, yeah. So if the assertions, you know what, if there was a problem with the assertions, if there was a problem with the assertions, then we would end up getting an exception, and we didn't get one, so we know that the assertions are true. So actually, let me just erase that. Here, 1 second. Okay. And let me erase the, okay, yeah. Let me just erase that and then put in some spaces so this is a little more readable. Looks a little better. Okay. And we're good. Okay, let me... let's see. Remove that cop. Ugh, why is that going on? I need to stop that. There we go. Okay. It's my touch bar. The touch bar at the top of my laptop is super sensitive. So if my fingers touch it just a little bit, I end up with a new terminal screen. So it's a little annoying. Sometimes I have to be very careful with my touchpad. Okay, so let's remove the copy and clear it. And let's see what I have here. Word in sentence is right over here. Python 3 word in sentence.py. There we go. So everything is fine. And my assertions did not raise any exceptions. So that means that the assertions are correct. So word in sentence.py. Yeah, if there was a problem with my assertions, if the assertions were wrong, then Python would return an exception. Python would raise an exception. But there wasn't an issue, so that there wasn't a problem with that. So everything worked fine. So it works. So yeah, there's no issue with that. So let's clear this. We can run it one more time just to make sure, but it should be fine. Okay, so everything, my tests are true, everything is fine, and we're good to go. Okay, so that function is great. Okay, so let's take a look now. 1 second, I just want to see one thing over here. Hold on. Where's my, there we go. Let me mark this so I can find it more easily later on. And there we go. Okay. So, oh, no. Why am I, wait. Yeah, that's fine. We could, okay. Let's, hold on 1 second. Okay. So, okay, I've got two terminal windows open, actually. Okay, so I'm going to close this terminal window. We're good. And I'll leave this one open in case I need it. Okay. Okay, so what do we have over here? Okay, excuse me. So the next problem is given an integer n, Here, guys, hold on 1 second. I'm going to pause the video. I need to check my phone messages very quickly, and then I will go back to this video. This is going to be a long video because we have a lot of problems to work on, so just bear with me, okay? Let me pause this, and we'll continue shortly. Okay, guys. So, oh, I'm losing my voice here. Excuse me. All right. Let's see. Okay, I may have to break this up into 2 videos because this video is starting to get a little long. Okay, so the second problem is given an integer n, excuse me, use the cashier's algorithm to find the change for n cents using quarters, dimes, nickels, and pennies. Okay, excuse me. So given an integer n, use the cashier's algorithm to find the change for n cents using quarters, dimes, nickels, and pennies. Why don't we use Mathematica for this? Let's use Mathematica for this, okay? So let me see. Input. Okay. Show fonts. And I'm going to make this kind of bit, oops, that is way too big. I want you guys to see this. So should we do 30? All right. And then output. And we'll do 30. Okay. And let's make this bold. Okay, Arial, I like Arial, and Arial. Let's play with the colors a little bit. We could make this blueberry blue, and this could be, what color should that be? How about a midnight blue? Midnight blue, okay. All right, I think that works. And where's my marker? Okay, so yeah, guys, we're gonna break this up into 2 videos because otherwise, I mean, this video is gonna become painfully long, and so yeah, we'll break this up into 2 separate videos. Okay, so I was hoping to do this in one video, but you know, it's gonna get really, really long. So okay. So let's see. Comment. Douglas E. Lewitt. In math 144 section 0C1. Okay, that's a comment. Excuse me. So in Mathematica, that's a comment. This is not a comment in Mathematica. Okay, the hash symbol or the hash mark, okay, in Mathematica, it doesn't mean a comment. That's Python. That's Python. This is Mathematica. It's a different programming language. Totally different, okay? Well, maybe not totally different, but it is different. It's very different. All right. So, and then I could say, let's see. I can't quite line that up that well, but that's okay. So, this is my solution to the cashier's algorithm for the first programming project. Okay, so there you have it. That's a comment. That's a comment in Mathematica. And this is what you should have at the top of your assignment. This is what you should have at the top of your submission. You should have your name and a description of what you're doing. So let's think about this. Let's say that I have 120 cents. So let's say I have 120 cents, okay? So how many quarters is that going to, how many quarters are in 120 cents? So we know the answer to that. The answer is there are four quarters. Okay, 1 second. There are 4 quarters in 120 cents. I mean, okay. Right? We do know that, right? Okay. So in Mathematica, a quarter is worth 25 cents, right? So it wouldn't make much sense to do that in Mathematica. And even if I did this, right, it still really wouldn't make much sense. Get it? Sense or sense? So just a little joke there. So, because remember, Mathematica is not Python, right? So what we could do, quotient 120, 25, and we get the answer of 4. That's integer division, right? An example of integer division. Okay. But then what is the remainder? What is the remainder? The remainder is going to be 120, 25. I know the remainder is going to be 20. Oops, it should be mod, hold on. Sorry, mod. There we go. The remainder is 20. So based on this, I could build my function. So what am I going to need? I'm going to need integer division, and I'm going to need the modulo function. Okay, so an example of the modulo function. Okay, terrific. So let's kind of experiment and see where this takes us, okay? So cashier's algo. Is that what I should call it? Cashier's algo. So let me see, what would be a good way to do this? I would have cents. This is a variable, guys. You need that underscore. You do need that underscore, right? And this is going to be, let's store the answer in my solutions. Okay. Actually, no, wait a minute. That would be, I believe I have to use the colon. Hold on 1 second. Let me make sure I'm doing this correctly. Oops, sorry. Let me make sure I'm doing this correctly. There we go. Yeah. So this is how you specify a default variable in Mathematica. You have to use the colon. So yeah, for a moment there, I kind of forgot. So there we go. Okay, so cashier's algorithm. So we have our cents. We have our solution, or solutions, you could say, or solution. It's an empty list. And then you have coins. And we're going to start with 25 cents. And let's see. Quarters, dimes, nickels, and pennies. Okay. 25 cents, 10 cents, 5 cents, 1 cent. Oh, there we go. Um, there are a couple ways of doing this. So this would be if sense less than or equal to 0. Okay. Or, that's the symbol for or logic, or the length of coins is equal to 0, so it's empty, then we're simply going to return the solution. Or I could put that on the next line. Let's return the solution. Otherwise, we are going to have, let me see, the head of my list, the coin is equal to coins 1, which refers to the first element of my list, semicolon, because I'm putting a bunch of statements together. Okay. Rest of coins will be, and I'm using camel case for that, coins, let's see, 2, -1. If I do that, by the way, guys, so this right here gives me the first, the first element of my list, and this over here gives me, everything else that's in my list. Okay, so that's what I'm doing. So this is called the head. One second. This is the head of my list, and this is the tail of my list. The same idea in Python, same idea in Racket, actually. It really is the same idea. Okay. So then, let me see. So we're going to do, what would be a good variable name? So Q is equal to quotient sense. Q is equal to quotient sense coin. Okay. M is equal to mod sense coin. Sorry about that. Q, and then we have M. So let's say 120 cents. We have 4 quarters. So then we're going to do, let me see. We're going to have cashier's algo. The remainder of what we have left, the remainder, which is M, we are going to have, we have to do a concatenation here. Hold on one second. Why am I forgetting this? Join. We have to use join. Okay. So if you use join, guys, what does join do? Join, this is what join does in Mathematica. Okay. It joins, or you could do it this way. I personally think this is a little uglier. You can do it that way, but it's not my favorite way of doing it. It's the same idea. Okay, so you're joining 2 lists together. Okay. So you would have to do solution join Q, and then replace the coins list with rest of coins. Okay. Let me see if this is going to work. Okay, so here we have our test. If this is true, return this. Otherwise, return all of this. So if this is true, give me back the solution. And if it's not true, do this block of code. Now remember, the statements in your block have to be separated by semicolons because otherwise it's just not going to work. Okay, it's not going to work. I'm making a video. I got the message. I'm making a video. I got the message.
Okay.
Yeah, I got the message. Thanks. Okay, so let's see if this is going to work. Cashier's algo, 120 cents. Okay, so this basically, it does work. I mean, it does actually work, but I do see a little issue with it. So I see, okay. So it basically does work. I have 4 quarters. I have 4 quarters. I have 2 dimes. I have 4 quarters and I have 2 dimes, which gives me, 4 quarters and 2 dimes gives me 120 cents. Now, the only problem is I would like to see, I would like to see, my preference is to see something like this. I would like to see 4, 2, 0, 0. So this tells me I have 4 quarters, I have 2 dimes, I have 0 nickels, I have 0 pennies. That's my preference. I mean, this works, this does work, but it's not quite what I want yet. But it's getting very close. Okay, so let's say, let me test this. Let me test this and make sure this is working okay. Cashier's algorithm. What about 96 cents? Okay, so we're going to have 3 quarters. 3 quarters. 3 quarters is equal to 75 cents. Okay. And then we have 2 dimes, and 2 dimes is equal to 20 cents. We have 0 nickels, and 0 nickels, well, that's equal to 0 cents. And then we have 1 penny, and 1 penny is equal to 1 cent. If I add that all up, well, we know this is going to be 95, right? And 95 plus 1 is going to be 96. Okay, so the problem is, there's just one little problem, and it's not that difficult to fix. Okay, we need to, here, 1 second. What if my list does not, what if my list is shorter than 4 elements? Right, so the length of this, what is the length of that list? The length is 4. Algo 96, the length is 4. Cashier's algo, right here, the length is only, is only 2. So that's not quite what I want. It's close. This is very good. It's very close, right? This is very good. This is like a B plus, or maybe an A. I'm going to give myself an A minus. Hey, if you're the teacher, you get to grade yourself. I'm going to give myself an A minus, okay? What I really want, though, guys, is an A plus. I really want this to be perfect, right? So how do I make it perfect? So I have to correct this little problem here. So what I could do is I have another function. There's nothing that says you need only one function. You could have 2 functions or 3 functions. You could, you don't have to use just one function. Use 2, 3, 4. I mean, use as many functions as you think you need in order to get this done, right? Okay. So I call this cashier's algo. So what I could do is cashier's algorithm cents, okay. Module is what you often use in Mathematica to declare, if you want to declare a local variable, a local variable. So this is going to be, I'm going to call this my almost solution. My almost solution. Let me put this on the next line, space. Almost solution, cashier's algo, and this is going to be cents. Okay. All right. So now I have to be creative. I have to think, how am I going to do this? Let's see. Constant array. Is it 0 to, yeah. So this is going to be my special function, or 0, 4, or whatever, 0, 0, 3, whatever. So this is constant array excuse me, is a built-in Mathematica function that creates an array of constant values for the user. Okay, there we go. So how am I going to do this? Okay, how am I going to do this? So this is what I propose we do. Okay. We could create another module. Okay. Solution length. Solution length is equal to the length of my list, which is, almost solution. Okay. Okay, and then we're going to have, let me see, almost solution, oops, sorry, join constant array 0 4 minus the solution length. Okay, let's see if this works now. Okay. How many quarters, dimes, nickels, and pennies do I need for $200 or 200 cents? Okay. Cashier's algorithm, 200. There we go. So it looks like I'm going to need 8 quarters, and then we have 0 dimes, and we have 0 nickels, and 0 pennies. All right, right? And what about cashier's algorithm? 209 cents. Well, we have 8 quarters as before to give us $2. We have 1 nickel, that's 205 cents, and then we have 4 pennies. Okay, what about cashier's algorithm? 210 cents. Okay, so we're going to have 8 quarters, we have 1 dime, that's going to be $2.10 or 210 cents. And then we have 0 nickels and 0 pennies. So here, we have 200 cents, that's going to be 8 quarters. We have 0 dimes, 0 nickels, 0 pennies. Here we have 209 cents or $2.09. 8 quarters, we have 1 nickel and 4 pennies. Cashier's algorithm, 210 cents or $2.10. That's going to be 8 quarters, 1 dime, 0 nickels, and 0 pennies. So we could make this even more interesting. We could make this much more interesting. So we could do let me see. We could do cashier's algorithm printout sense. Okay. And we could say, well, actually, before I do that, hold on one second. Cashier's algorithm, what about 4 cents? It works great. Okay. And we're not going to use negative numbers. Do not use negative numbers. That's not going to work. Okay. So cashier's algorithm printouts cents. Okay. Module solution. Okay. The solution is going to be cashier's algorithm cents. And then what we're going to do is print, oh, wait a minute. I need a comma here, sorry. I need a comma. Print number of quarters, string join, and that's going to be toString solution 1. And, oh, 1 second. There we go. Print number of dimes. Actually, that would look much better. Number of dimes, string join. Or actually, instead of string join, you know what you could do? This might look a little nicer. That's the symbol for string concatenation in Mathematica. Or you could use string join. That's up to you. toString solution 2. Print number of nickels. toString solution 3. Oh, wait 1 second. Why am I getting, oh, there we go. I see what's happening. Okay. And then print number of pennies. toString solution 4. The only problem here, well, it's probably not going to look very, well, okay, let's see what it looks like. It's probably not going to look that great, but it should be mathematically correct, but the output may not look very pretty. So cashier's algorithm printout 128 cents. Yeah, you can hardly see it. So we can you can hardly see the answer. So we can change that. Let's use style. Let's see. Font size will be, I don't know, let's say 26. And font weight could be bold. And font color could be magenta. Okay, we could do magenta, or maybe that might be a bit much. How about purple? Okay. Do the same thing here. Oh, I forgot. Let's do style. Okay, and let's see. Font size is 20. Oops. Font size is 26. Font weight is bold. Font color is purple. Okay, do the same thing here. Style. And, oh, wait a minute, why? Oh, there we go. And hold on one second. There we go. And we have font size is 26. Font weight is bold. Font color is purple. We could do the same thing right over here. Style. Font size is 26. Font weight is bold. And font color is purple. Okay, and I think we should be good to go. Shift Enter. So let's see what this looks like. Cashier's algorithm printout, 128 cents. So the number of quarters is 5. Does that make sense? Yes, it does make sense, because what is 5 times 25? 5 times 25 is equal to 125. And what's left over? We have 3. We have 3 left over. So we have 5 quarters is 125 cents. We have no dimes, we have no nickels, and we have 3 pennies left over. And if you do, 1 times 3 is equal to 3, and then we're going to add that up. What do we have? We have 128. Okay, so really not that bad. And actually, this is a little small. We could do 30, we could do 30, we could do 30, we could do 30. Okay, let's do, here we go. That looks a lot nicer. I want to see some test cases, right? When you turn this into me, guys, I want to see test cases. I really want to see test cases. That's important. Don't just give me a function. Like, don't just give me a function, right? I want to see test cases. Now, by the way, this is really important, and some of you maybe don't understand this that well. I have 3 different functions here. I have my original function, excuse me, I have my original function, which is called cashier's algo. And then I have, this function over here, cashier's algorithm. And then I have this function over here, cashier's algorithm printout. So cashier's algorithm printout uses the output of this function, cashier's algorithm, right? And cashier's algorithm uses the outputs. So wait a minute, let me go back to this. Cashier's algorithm printout uses the output of cashier's algorithm. Cashier's algorithm is a function that uses the output of cashier's algo. There is nothing wrong with doing that. You don't have to have everything packed into just one function. I mean, if you try to do that, you're going to make yourself really miserable. All right, there's nothing wrong. There's nothing wrong with taking the workload and spreading it out over a whole bunch of functions. That makes perfect sense to me. Don't try to put everything into one function, because if you do that, you're going to make yourself nuts. You're just going to make yourself nuts, okay? So I want to see test cases. So cashier's algorithm printout 133 cents. So I have 5 quarters. 5 quarters is 125. Wait a second. Yeah, I have 5 quarters. It's 125 cents. I have no dimes. I have 1 nickel. That's 130 cents. Then I have 3 pennies. Okay. So what about Cashier's algorithm printout, right? So no quarters, no dimes, no nickels. I have 1 penny. What about, let's see, 1,009 pennies. This would be $10.09. Okay, so that's going to be 40 times 25. And we have 4 pennies. So let's see, number of quarters. Oh, we have 1 nickel, right? We have 1 nickel. We have 1 nickel, 4 pennies. So 1 nickel and 4 pennies, that gives me the 9 cents. This is $10.09, right? And what about the 40 quarters? So we have 40 times 25 cents, right? That's going to be 0. 4 times 5 is 20, and we have 0 times 2, and 4 times 2 is 8. And we have 0, 0, we have 10. That's $10. So 40 quarters is equal to $10. Okay. And then we have 1 nickel and we have 4 pennies, and that's equal to 9 cents. So we can see that 40 quarters plus 1 nickel plus 4 pennies has to give us $10.09, which is the same thing as 1,009 cents. That's the symbol for cents. Okay? Okay, so I think, here, 1 second, let me move my laptop a little bit. Okay, guys, so I think this video has gotten long enough. We still have 3 more problems to do. And don't worry, I didn't forget, I got to grade your submissions. I have to grade your assignments, okay? And yes, I will do that. Don't worry about it. Just give me some time. It's going to take me a few days to review all of your stuff, okay? So let me see what we have here. Let me see. Okay, these are my test cases. So guys, moral of the story is this. The moral of the story is this: when you do a submission, when you do a project for me, when you do a programming project, I really want to see a comment at the top that identifies the name of the student. You have to have a name. I want to see a name, and I want to see, you have to identify the problem. Which problem are you submitting? Which problem are you doing for your project? And then I want to see, what are you doing? Like, I want to see your work. And then at the very end, and this is really important because you can be sure I'm going to spend a lot of time looking at this, I want to see test cases. I want to see test cases. Okay. Cashier's, Cashier's algorithm printout, $5.47 or 547 cents. Shift enter. Okay. I really want to see test cases. That's really what I'm going to spend a lot of time looking for. If you don't have test cases, guys, then what you're doing is you're basically giving me a lot more work to do. If you're giving me more work to do, I'm going to have to start taking points away from your projects. All right, so I want to see test cases. You can't just give me a function and say, hey, here's my function. I want to see how you are actually, excuse me, I want to see how you are applying the function. How are you applying the function? That's really important. How are you applying this function? I've got to see that, guys. I absolutely have to see that, because if I don't see that, then it's like, oh, what the hell is this? All right, guys, I'm going to email you these 2 files, the Python file that I created and the Mathematica file that I created. I will email these to you. And I will also post this video to YouTube, and I will post this video to the course shell. And yes, sometime, I don't know about today. Today is October 30th. So this weekend, I really have a lot going on. Actually, this whole semester, I have a lot going on. So I don't think I'm going to start grading your projects today, probably tomorrow. If not tomorrow, for sure on Monday. For sure on Monday, I'm going to start grading your projects, but please give me a few days. It will take me a few days to grade all of the projects. This is actually a big class. This is a big class. I have a lot of students in this class. So it's going to take me, at least a couple days to get through everyone's submissions. All right, guys. Um, that's it. And I hope you learn. And I will make another video, guys, because I remember um, we have to go over these three problems. Okay, this one here, problem 26 from section 4 of chapter 4, and then yeah, these two problems over here. So for this problem here, for 26, I'm probably going to use rackets. I think I'm going to go ahead and use racket for that one. And maybe for number 9 and number 10, I will use Python. Okay. But yeah, but I'm going to save that for another video, guys, because this video is long and it's gotten long enough. This video is already it's pushing an hour and a half. That's pretty long, I would say. It's pushing an hour and a half. So we're gonna call it quits for today. I will try to make another video tomorrow, and then on Monday I'm gonna start grading your projects. And then sometime this week I have to put together your second and your third projects. Okay, so there's plenty of work for me to do. Okay, take care, guys, and I hope this was a very helpful video for you. Okay, take care, and that's it. Happy Halloween. Bye-bye. Happy Halloween. Take care.